Dear students, as I have discussed in the last lecture that we have to study about the sudden short circuit of a synchronous machine. As this topic is a part of symmetrical short circuit analysis, but as per your syllabus, as I have told you previously, this is given in the synchronous machine topic in your syllabus, RTF curriculum syllabus. So now this lecture is basically on the short circuit of a synchronous machine on no load condition. So this is the diagram of a synchronous machine, steady state short circuit model of a synchronous machine. Under steady state short circuit condition, as you have already studied in the subject of machine, the armature reaction of a synchronous generator produces a demagnetizing flux. In terms of circuit conditions, in terms of this, consider now, in terms of circuit condition, this is modeled as the XD is the direct axis synchronous reactance, which is a combination of XA in series with the induced EMF. XA is the armature reaction due to the reactance of armature reaction XA, and XL is the leakage reactance. When we both combined as XA plus XL is known as the direct axis synchronous reactance of the machine, and with the series of induced EMF. This is the basic steady state condition or basic theory of the synchronous machine, that whenever the circuit is energized, the induced EMF will generated, and in series with the armature due to the armature reaction, the reactance of the machine is offered as a armature reaction plus leakage reactance of the machine, which is a direct axis synchronous reactance. So this is the steady state condition of a synchronous machine. Now consider now the sudden short circuit. Suppose a three-phase fault occurred at the machine terminal on no load condition. Now what happened with the machine? Then a synchronous generator initially operating under open circuit condition, the machine undergoes the transient in all the three phases, finally ending up to the steady state condition. Means whenever the sudden short circuit will occur, then the transient in all the three phases will occur, and uh, due to this transient, one thing I have mentioned here, that immediately upon short circuit condition the DC offset current will appear in all the three phases, but in the in this study we did not consider the DC offset current. We added the DC offset current with the symmetrical short circuit current, which is AC1, by the empirical basis. So in today's lecture or in today's this topic, we will not consider the DC offset current. We will only consider the symmetrical short circuit AC current. So as the sudden short circuit will occur, the transient will appear in all the three phases, and since the air gap flux cannot change instantaneously, the to counter the demagnetization of the armature short circuit current appear in the field winding as well as in the damper winding. So at the time t is equals to 0, sudden short circuit will occur. Then at t is equals to 0 plus, the current will appear in the damper winding as well as in the field winding, which is come in the parallel to the armature reaction in reactance. So at t is equals to 0 plus, or we can say at from 2 to 3 cycle of the sudden short circuit, the machine will offer the reactance like that the leakage reactance in series with the parallel combination of damper winding, field winding and armature reactance. So the total reactance of the machine will reduce, and the when the total reactance is reduced, the current will higher. Just a, so total reactance is reduced and current will become higher. To counter the demagnetization, the armature short circuit current appear in the field winding as well as in the damper winding, which is in direction to the help to the main flux. Now the current decays according to the winding time constant. According to the winding time constant, the current decays. The time constant of the damper winding, which is low leakage inductance, is much less than the that of field winding, which has high leakage reactance. So after some time, according to the winding time constant, first the current will die out from the damper winding. Now the XF field winding and armature winding will only come in the picture. This is called this condition is a subtransient condition. We said the name given as a subtransient condition, and this condition is known as a transient condition. And after some time, the field winding current will also decays and machine reach under steady state condition, which is the XL plus XA. So we can understand the sudden short circuit of synchronous machine in three parts. One is the synchronous, one is the steady state condition where XF and XA are in parallel. Then subtransient condition when XDW, XF and XA will in parallel with the series with XL leakage reactance. And third one is the transient condition where XDW damper winding constant is first die out and XF and XA will become in parallel, and with the series with the XA. Again, then finally, steady state condition is reached when the current in the field winding has been die out and XA and XL will only come in the picture. So this is the three circuits or three models which machine offer when the sudden short circuit will occur. Now we will discuss about the total inductance and current in these three conditions. During the initial part of the short circuit, the damper and field winding have transformer current induced in them, so that the circuit model has reactance XF of the field winding and damper winding appear in the parallel. So in case of subtransient condition, the total inductance or reactance of the machine is XL plus parallel combination of XA plus XF plus XDW, damper winding, field winding and armature reaction. So the parallel combination of three when combined with the leakage reactance in series, then the reactance is known as the XD double dash, which is a subtransient reactance. While in case of transient reactance, only XA armature reactance and field winding will parallel with the combination of leakage series with the leakage reactance. It is known as the XDW. And finally, the steady state reactance is known as XD, which is the combination of XA plus XL. If we compare all the three reactants, then the XD is the highest, XDW is the greater than from the XD, so less than from XD, and XD double dash is lesser than all of in between all of three. So if the XD double dash is higher, sorry, XD double dash is lower, then current will become higher. So in case of subtransient, the current is highest. After that, in the transient, current is low from the subtransient condition, and finally current will be in the steady state condition. This is represented as a, this is the symmetrical short circuit waveform. This 0, this is the time horizon 0. OA is the steady state current limit, OB is the transient envelope, and OC is the subtransient period or subtransient current. In the starting of 2-3 cycle, the subtransient condition will exist. After that, transient condition will reach, and finally the steady state condition will occur. If we make the envelope of the current, then the current I, which is the steady state current, can be represented as OA upon root 2 is the RMS value, which is the modulus of EG upon XD. I dash is the transient current, is the OB upon root 2, which is modulus of EG upon XD dash, and subtransient current, which is the OC upon root 2, which is the EG upon XD double dash. So this, according to the time period, the current will divide into three parts: transient current, subtransient current, and steady state current. Similarly, the reactance had three types: XD double dash, XD dash, and XD. XD double dash is a direct axis synchronous reactance. XD dash is a direct axis, XD double dash is a direct axis subtransient reactance, XD dash is a direct axis transient reactance, and XD is the direct axis synchronous reactance. This is the three types of reactance and three types of uh, current will occur. Highest current will be in the subtransient condition, and after that the current will decrease, and finally the current will reach at the steady state condition. So this is all about the steady state or symmetrical short circuit as a synchronous machine terminal. Machine will react as three part, which we will discuss. So this is all about the steady state circuit of the synchronous machine. Thank you.